Hey everyone. So today we are going to study clamp coupling, or it is also known as compression coupling. Compression coupling, or also it is known as split muff coupling. Split muff coupling. So in this case, the muff or sleeve is made in two halves. So this is made in two halves and are bolted together, and the halves of the muff are made up of cast iron. So similarly, in sleeve coupling, the sleeve was made of cast iron. Here also it is made of cast iron. The shaft ends are made to abut each other, and a single key is fitted directly in the keyways of both the shafts. So one half of the muff is fixed from below and other half is placed from above. So both the halves, so here in split coupling, so one half, so suppose this is the one half and this is the second half. So this is the one half and second half, so this is split coupling type. So both the halves are held together by means of a mild steel or studs or bolts and nuts. So number of bolts may be 4, 6 or even 2, 4 or 6. This nuts, so this is combined with the help of nuts. So these nuts are recessed into the bodies of the muff casting. So this is recessed in this inside this body. In this coupling will be used for heavy duty. So it is used for heavy duty and moderate speeds. Heavy duty and moderate speeds. So the advantage of this coupling is that the position of the shafts need not be changed for assembling or disassembling of the coupling. So here, uh, as we know that if the shaft here, it is, suppose they are both near, so we don't have to change the position in order, because from up and down we can combine the coupling. So the usual proportions of the muff for the clamp or compression coupling is capital D. The diameter of the sleeve is 2D plus 13 mm and length L is 3.5D. So the diagram will be similar to the sleeve coupling. That is, so suppose this is a shaft. This is the center line. This is the side view. So this is the key, and this is the muff. This is shaft. This is the key. This is the muff or sleeve. This is the diameter of the shaft is small d, and the diameter of the sleeve is capital D. Now there are also studs here. This is bolted with screws and nuts. So if here we see from left hand side view, so we can see here that there is a nut bolt mechanism here and here, and between there is a shaft. So this is the left hand side view. So in the clamp or compression coupling, so this is clamp or compression coupling, the power is transmitted from one shaft to another shaft by means of key and friction between the muff and the shaft. In the designing this type of coupling, we will use the procedure. It is number one, design of muff and key. First, so the design of sleeve and key will be the same as we have used in design of sleeve coupling, so we will not discuss this here again. So we here the one thing which is new, that is the bolts. So we will see here the design of clamping bolts. So let's say T, capital T is the torque to be transmitted by the shafts. Small d is the diameter of the shaft. Diameter of shaft. Similarly, capital D, then dB is the root or effective diameter of the bolt diameter. Then N is number of bolts. Then sigma T is the permissible tensile strength. Permissible tensile strength. Mu is the coefficient of friction between muff and shaft, and L is the length of the muff. So we know that the force exerted by each bolt will be equal to, what is force? That is stress into area, that is pi by 4 d square, pi by 4 dB square into sigma T, tensile stress. So force exerted by the bolts on each side of the shaft will be pi by 4 d square sigma T into n by 2. So number of bolts divided by 2. So now let P be the pressure on the shaft. Let P be the pressure on the shaft and the muff surface due to the force. Then for uniform pressure distribution over the area, P is equal to F upon projected area. P is equal to F by A. So force F is equal to pi by 4 dB square sigma T into n by 2 divided by 1 by 2 L into D. So force we have taken this pi by 4 dB square sigma T, and area. So what is the projected area? That will be equal to length into diameter. So 1 by 2 length into radius. So 1 by 2 L into D. So frictional force between each shaft and muff will be equal to, F is equal to mu so frictional force F between each shaft and muff will be equal to mu into pressure into area. So mu into pressure, that is P, this is the pressure, into area. So area is 1 by 2 pi d into L. So if we apply this formula here or substitute, so we'll get mu into pi by 4 dB square sigma T n by 2 divided by 1 by 2 LD into 1 by 2 pi dl. So if we cancel out this 1 by 2 and L, so we are left out with, and also D and D. So here we are left out with frictional force F will be equal to mu pi by 4 dB square sigma t n by 2 into pi, and the torque transmitted will be equal to T is equal to force F into radius, that is d by 2, so which will be equal to this into d by 2, so it will be equal to pi by 4 into 2 into 2, so pi by 16, and pi is pi square mu dB square sigma t into n into d. This is the formula for torque. So from this relation the root diameter of the bolt dB can be evaluated. So this dB can be written with the help of this equation. Now we'll see an example so it will be more clearer. Now here there is an example. Design a clamp coupling to transmit 30 kilowatt power at 100 rpm. So here it is given P is equal to 30 kilowatt, that is 30 into 10 to 3 watt, and N, that is speed, is equal to 100 rpm. The allowable shear stress, that is sigma, that is tau. So allowable shear stress is tau for shaft and key is 40 megapascal, and number of bolts connecting the two halves are 6. So N is given as 6. The permissible tensile stress for the bolts is 70 MPa. So sigma T is 70, and the coefficient of friction between muff and shaft is mu is given 0.3. So now let's design first for shaft. So design of shaft. So for design of shaft, first if we want to find the diameter of the shaft, so let first small d is equal to the diameter of the shaft which we have to find. So now first the torque T will be equal to P into twice by N by 60. So torque will be equal to power P is given 30 into 10 to 3 watt, and N is given 100 rpm, so which will be equal to 2865 into 10 raised to 3 Newton mm. So we also know that the torque transmitted by the shaft T is equal to pi by 16 tau d cube. So if we make d as a subject, then we will obtain the value of the diameter d. So and T we have, that is 2865, pi we know 3.14, tau we have 40 megapascal, so we'll get d. So if we solve this equation, so we'll get d will be equal to 71.4, so which we will round off because of standardization, so that will be equal to 75 mm. Now second, design for muff. So if we want to design for muff, so we need to find the diameter of muff and the length of the muff. So for diameter of muff we know that is 2d plus 13, so which will be equal to 175 into 2 plus 13, so which will be equal to 163, so which will be equal to, we round off, 165 mm. Because of standardization we will round off, and L is equal to 3.5d, so which is equal to 262.5 mm. So this is the design of muff. Now third is the design of key. So for design of key, we need to find here width and thickness of the key. So the width and the thickness of the key for shaft diameter of 75 mm from the design data book will be equal to W is equal to 22 mm, thickness T is equal to 14 mm, and the length of key will be equal to the length of muff. So L will be equal to same 262.5 mm. So this we have taken from design data book. This too. So which is equal to 262.5 mm. Now fourth, that is design of bolts. So as we know that we have total n, that is 6 bolts. So we need to find here is dB. So that is root or core diameter of the bolt. That's dB is equal to root or core diameter of the bolt. So for that we know the formula T is equal to pi square 16 mu dB square sigma T n into D. Now the torque T we have here, that is 2865 into 10 raised to 3 is equal to pi square divided by 16 into mu it is 0.3, mu is 0.3, into dB square. dB we have to find into n is 6, and small d diameter of the shaft, that is 75 mm. So if we substitute, if we make dB as a subject, so we will get dB will be equal to 22.2 mm. So from design data book we can find a standard core diameter of bolt for core series will be equal to 23.32 mm, and the nominal diameter of the bolt will be equal to 27 mm. So this is standard core diameter, and nominal diameter of the bolt will be equal to 27 mm. It is M27. So this is the design of the clamp coupling. So we have seen the theory and also one example, so we get a better idea of this. So in the next lecture we will see flange coupling. So there total we will see 4 to 5 types of coupling in this chapter. So thank you very much. So I will just revise what we have learned today in this lecture. So here in camp or compression coupling, which is also known as split or muff coupling. So in the previous lecture we have seen a sleeve of muff coupling, and here in clamp coupling. So here is the difference is that in this case muff or sleeve is made up of two halves, so it is divided between it in two halves. So the shaft ends are made about, and a single key is fitted directly in the keyway of the shaft. So this benefit is of this is that coupling is that position of the shaft need not be changed for assembling or disassembling of the coupling. This is the main benefit of this coupling. So we have seen here design of muff, that is design of sleeve, then key, and design of bolts. So this is the clamp, we can call it a clamp coupling. So